All right, guys. So today we're going to talk about data and parallel processing. So as I'm sure you know by now, and maybe I've mentioned in other videos, parallel processing is the ability to do multiple lines of work at the same time in order to accomplish some result or some calculation or whatever it is you need to do. Parallel processing by definition is very fast. So you know what would take the CPU, which has a single line of work, maybe a minute to do. If you were to parallelize the process for things that can be parallelized, it might take you a whole lot less, 10x less, 20x less. Just very, very fast. But the problem that you have with parallel processing that you're inevitably going to come up against is that the bottleneck is going to be data. So you're processing these things very fast, and of course when we're performing work on a computer, we're not just juggling around random numbers that we created out of the sky. We're actually processing data. So it could be visual data, it could be statistical data, it could be data from like an Excel spreadsheet, millions and millions of rows and columns and all of that. We're working on data and we need to process the data to get some result. But if your parallel processing system cannot access the data, or if the memory situation isn't quick enough, what's going to happen is that you're going to starve your parallel processing algorithm. What I mean by starve is that basically you're processing faster than you're accessing the data, and then your memory becomes a bottleneck in holding back the whole algorithm. Now, this discussion is so important. It's such an important discussion that Nvidia recently bought a company by the name of Melanox for $7 billion US dollars. Okay? Lots and lots of money. Why did Nvidia buy Melanox? Melanox is a company that specializes in networking technologies and data and memory access and all this stuff, right? And efficiently shuttling around data from one location to the other, etc., etc. This conversation is so important that Nvidia was willing to spend $7 billion US dollars to acquire this Melanox company so that they have the memory and data transfer and networking technologies and expertise in-house at their company. And again, if you don't have your memory and data situation sorted out, you're going to limit the potential of your parallel processing algorithm or system or whatever. Now, remember that a lot of times, at least in my experience with my Nvidia Cuda, tutorials, you have two worlds. You have the CPU side and you have the GPU side. Okay? And a lot of times what would happen is that you have to shuttle data from the CPU over to the GPU, right? Because again, the parallel processing is happening on the GPU side. Okay? So your regular computer system and what have you, your laptop or your desktop or your enterprise computer or your server, whatever it is you have, generally speaking, the data that you want resides over here. but the parallel process resides over here. So I have a tutorial about pinned memory that talks about telling the CPU to section off a certain portion of its memory and prepare that portion of memory to be quickly accessible by the GPU, so that the GPU is able to quickly access the data and do what it needs to do. It's faster than using unpinned memory, because unpinned memory is going to be it's randomly allocated, it's not organized, it's not set aside, and it's not as coherent and what have you. So I had to have a tutorial called pinned memory and using it to make your algorithm run faster, because it can access the data faster. Now, a lot of times, just so you understand, after the data is processed, so after you do processing, you're gonna push back the data to the CPU, right, to do further calculations or whatever it is you want to do. But this data now is usually the results, right? Results after processing. Okay, so you're pushing the results after processing back to the CPU, and then you could continue with your algorithm. All right, so that's a conversation around pinned memory and trying to help your system to manage this process, or basically make your algorithm run faster. All right, so now there's another tangential conversation that I guess I could use this thing right here to just continue the conversation. So there's another thing that's sort of related to this, and the guys from Nvidia talked about it. It's called dynamic parallelism. And basically what this is allowing you to start other CUDA kernels on the GPU itself. So normally you would have like an initial CUDA kernel launch, and then it's launched on the GPU, but then the GPU can also initialize other CUDA kernels implicitly, so it doesn't have to go back to the CPU to get validation or to get to get initialization or anything. The GPU, based on the results of the first CUDA kernel, can launch other CUDA kernels to process more data. There was a presentation about this that spoke about, for example, when you're processing certain pieces of visual data, and then you want to zoom in because maybe that area of data that you're seeing, that area of data that you're seeing is more interesting, or there's more things happening, so you want to zoom into that area and do further processing. Well, maybe whatever the camera is picking up, or whatever the phenomenon is being done on the visual data, maybe it's happening so fast that you don't want to have the latency of having to go back to the CPU to launch another kernel. You want to just be able to drill down into what's going on right then and there from the GPU itself. And all of this process perhaps can be crippled if you can't access the data if you can't access the data fast enough. So this is just another way that parallel processing inherently depends on your data setup, on your memory setup, how fast you're able to access these things, etc., etc. So I do have a tutorial on dynamic parallelism. This is also related to Nvidia Cuda. So this is all of this, relates to Nvidia Cuda, because that's the experience I have with parallel processing is through the Nvidia Cuda language, which is a proprietary language only available on Nvidia GPUs. So anyway, guys, that is my lesson for today on data and parallel processing. Please let me know your thoughts in the links in the comments below. Please remember to subscribe. I will add the links to these tutorials below and all that good stuff. But parallel processing is the future. It's used in autonomous driving. It's used in artificial intelligence. It's used in data science, data processing. It is the future simply because it's fast. There are certain limitations as to what you can parallelize, certain algorithms, calculations that aren't open to parallelization, because you have to do the first set of calculations before you can do the next set of calculations. But that's a different topic. Anyway, guys, I hope you enjoyed this video, and see you next time.